Before we start to develop the robot control, we define different areas. First, the magazine, the conveyor belt, the rotary table, the home position, and the idle position. Later, we will use these areas to avoid collision. In the home position, the security system allows to open the door, and in the idle position, the robot do nothing. In the Siemens TIA portal, you can define user constants. This is here done under PLC tags, user constants. In this constant table, every range has its own value. For instance, rotary table has the integer value 5. Later we can define, for instance, a variable robot in area, and if robot in area is rotary table, then collision problems in rotary table are possible. Now we will discuss robot control on PLC 2. Robot control is a composition object. Inside are information for collision detection. In object-oriented languages, they are called properties, and control languages static. Collision control calculate collision and set static collision detection. Robot communication is the interface between PLC and robot. Most manufacturers have such interface in hardware. We use an interface in software. For our type of Mitsubishi robot, there is no hardware interface available. In this project, the software interface has not all robot commands implemented. Therefore, a hardware interface is better. To connect collision control to collision detection, we need a PLC data type. In the TIA portal, project tree, PLC 2, PLC data type, we find the data type collision detection. In other programming language, it's so-called struct. We now will look on data type collision detection. The input is input request robot command, and the output request robot command allowed. If it is true, the robot command is allowed because there is no collision. We need the geometry of area magazine and the geometry of area conveyor belt and the geometry of area rotary table to detect collision. Every geometry has inside a struct calculate actual position. This calculates the actual position of the robot. Every geometry has inside the struct calculate request position. This calculates the request position of the robot. With this information and the information about the geometry, we can detect if the output request robot command is allowed. In our project, collision detection is calculated by collision control. But there is another option, an event-driven, sent from PC by S7 communication. This is sensible if we have a flexible production line. Now we look into the object Order Processing SFC. Order Processing SFC is a composition object. The static variable or code properties is robot trajectory. In robot trajectory are all informations about the possible robot trajectories in our project. Trajectory control reads one trajectory that is now active. Manage trajectories manage the necessary trajectories for one order. Here we see an example of an robot trajectory 1 from magazine to rotary table. Other robot trajectories are necessary for one order. In the TIA portal project tree PLC data type, we have another data type called robot trajectory. Now we look inside this data type. In the first line, it is robot trajectory number. In our example before, this was number 1. Robot trajectory is a two-dimensional array, the row for the different trajectories and the column for the sequential commands. A level deeper, we have a struct robot command and no motion in area. In this example, robot command is 11, and if robot command is 0, then we have no more robot commands. For this robot command, no motion in area is 0, and that means there is no condition. In this robot command, no motion in area is 5. If 0, then no effect. If 5, that means rotary table, then waits with robot command until rotary table has no motion. The gain of the PLC data type is that we can access to the properties robot trajectory only by one name. In this example, the properties robot trajectory are inside the composition object Order Processing SFC and inside PLC2. Another option is event-driven, sent from PC by S7 communication, and this is better if we have a flexible production. We have a short look on the TIA portal, here devices and networks, to see the configuration for this option event-driven send from PC by S7 communication. We have here in our device and network a PC system 2, and this PC system has a CP, that means communication processor. This is an internet controller, and with this controller the PC system is integrated in our Ethernet. We can have an additional component that is here under Thematic Controller Application, Thematic WinAC RTX, and we can put this here in this PC system, and then our PC has a real-time operating system, and he can work as a controller the same as a PLC. We can change here from network to connections and then to S7 connection, and if we connect the both systems, PC system 2 with PLC 2, then we have an S7 connection between both systems. This is a precondition for an event-driven communication between PC system 2 and PLC 2, and we can event-driven transfer a data block from PC system 2 to PLC 2 for control the robot system. Another option is to move the software from PLC 2 to PC system 2, for example, the software for the magazine. There is another option. If this is the magazine, then I can select network, and for PLC 2 the operating mode is I/O device, and I select PLC 2. Then we have a new Profinet I/O system between both partners. Now we have an hierarchical Profinet I/O system. PC system 2 has communication with PLC 2, and PLC 2 has communication with PLC 1. PLC 1 cannot have communication with PC system 2. And if this is a magazine, we can use this hierarchical system to connect the magazine to other robot cells, and the magazine has only communication with a PLC on every robot cell on the highest level. There are many methods of simulation and testing of PLC and HMI. The red one are inside the TIA portal, and the green one are not inside. First, the simulation of the PLC program. The simulation of one or all objects in control language called function block in one PLC with PLC Sim is possible. The simulation of all function block in two PLC with PLC Sim is possible. Then I have two instances of PLC Sim. The simulation of PLC with process simulator is possible. The process simulator is not inside the TIA portal, and process simulators are very expensive. For the simulation of HMI systems, there are different methods. The simulation of HMI with text simulator needs no PLC program. The texts are inside the list. The simulation of HMI with PLC Sim is possible, but you need the PLC program. The simulation of HMI with process simulator is very comfortable, but the process simulator is expensive. Now we speak about the test real process with HMI test functions. The test of one function block in one PLC with HMI test function is possible. The test of all function block in one PLC with HMI test functions, and the test of all function blocks in two PLC with HMI test functions. At the end, the test of the real process is necessary. Here you see an example of a process simulator for this robot cell. We have seen this production in video 1. The robot picks up the upper part of the relay and then the rotary table. The rotary table works and then the press. Then the optical check. The rotary table works and then at this point the electrical check. Now the robot picks up the complete relay, put it on the conveyor belt. The conveyor belt transport the relay outside of the robot cell.